As the sun hits the Earth's atmosphere, there's differences in temperature. And those differences in temperatures causes a wind to be blown. And as that wind blows on the ocean surface, it skims across the top and it moves the water to create these waves. And as these waves get formed, they travel long, long distances and then arrives here on Hawaii shore. We have those great waves for two reasons. One is in the wintertime, we get these storm-driven waves, and it's not even necessarily a storm that's here on Oahu or in the Hawaiian Islands. It could be a storm off Alaska that creates these waves that travel all that thousands of miles to get to here. And when we get it, we see it in these magnificent surf. That's one type of wave. The other type of wave, as you all watch the weather forecast at night, you see these trade winds that come in. It's anywhere from 5 to even 25 miles an hour. Now those types of trade winds also create waves, and those are locally generated waves. And that waves with the storm-driven waves makes this an ideal place to test our project.
Hawaii has one of the highest, if not the highest, amounts of wave energy in the world, so it's an excellent, excellent site. All right, we're here in the control room at the Marine Corps base in Hawaii, where the power is brought back in from the buoy that's about a mile offshore. You've seen the buoy out of the water, and I think you can recognize it from this diagram here. This is the large section you saw with the mast and the large buoy shell. I think when you saw it last, it was laying on its side at Pier 41. This drawing depicts how the energy is produced and how it gets back to the electrical grid. And the buoy, when it's put in the water, is attached to an anchor that's already out there. This anchor weighs 100 tons. It's enough to keep the system from moving around in the heavy seas that you get in Hawaii. And the buoy shell moves up and down as the waves come by. And we have a hydraulic ram here that connects the buoy down to this column that's on the anchor. And when the buoy moves up and down, it pumps this cylinder and pumps hydraulic fluid back to a hydraulic motor.
And this fluid will move and it'll turn a motor, and a motor goes in one circular motion like this, and then the motor in turn will turn a generator, which also moves in this direction.
The rest of the equipment converts the output of the generator into usable electricity that winds up back into the power grid that's here at the Marine Corps base. The equipment that's used to transfer that energy is all located down on the bottom of the sea in these watertight containers. There are several of them. This one houses the generator, which we see here. This one houses a transformer, and the last two house units that convert the power to make it a nice usable form so it can be hooked up to the grid. There are electrical connections that are made between this equipment back to shore, and there's also hydraulic hoses that go from the cylinder back over to the generator as depicted right here. There's other units shown here. This is the junction box on shore, and we can see where the power cable comes up from the ocean, runs through the junction box, and this is where we hook up new cable, and this comes all the way back up to the control room. And this cable comes up into this bunker, and this cable runs about almost a mile from this control room out to the buoy. Also in the control room we have other fault protection equipment, so if there's any electrical problems, the system shuts down and it's very safe for any people that are working near the equipment, and if anything happens out in the ocean, the electrical current is turned off and we don't have any safety problems. So this is all the equipment that's out in the ocean is the buoy and its anchor and the power conversion equipment. And then in the control room where we are right now, we house the fault protection equipment and the controls. There's also fiber optics that are used to transmit communications and control information. And the fiber optics transmit light, and the light is actually used to transmit information right back to the control room here. And it's a very fast way to communicate what's going on inside the buoy and all the sensors. In addition, in the control room, we send the information and the data via the internet back to various internet sites, so we can observe the operation of the buoy just by logging onto an internet site. We can do that anywhere in the world and observe how the system's working.
Now the energy in the waves, if you look at how much kilowatts of energy, you can get 100 kilowatts for every meter of wavefront. So if you're looking at a wave and you measure not vertically, not the height of the wave, but if you measure horizontally the length of the wave, for every meter here in Hawaii, you get 100 kilowatts. There's enough energy in the waves in Hawaii to generate electricity for every household on all the islands.